Hi guys, my name is Dean, and in this video I will show you my solution to advent of code problem of day 7. I will try to explain my thought process and why the code is written that way. The code will be available in my GitHub account and the link will be posted in the description, and feel free to use it. We will now take a look at the problem of day 7, which is titled Camel Cards. And as per usual, there will be paragraphs of red herring. You just tell a story, but it's not relevant to the problem at all, and try to skip. And I think it's safe to say when you see all these highlighted words to come by, and the problem will be described there. Now is the right time to pause the video and read the question by yourself, and I will then try to summarize the problem for you, and we will start from there. Okay, now I will give you the summary of the problem. And so camel cards is just similar to poker. You will be given 5 cards where each card has a strength of like ace, king, queen, 5, 4, 3, 2, and where 2 is the lowest. And then among these 5 cards you can have combination, or we call it type here, and this combination can be 4 of a kind, full house, 3 of a kind, 2 pair, 1 pair, just like poker. The difference between with camel cards with poker is you don't have straight, as 2, 3, 4, 5, 6 will just belong to a high card, and you can also have a 5 of a kind where all the 5 cards is on the same type. Another thing that is different from poker is after comparing all this combination, if 2 hands have the same type, they will then go for sequential ordering. In poker, if the hand is 3-3-3-2, it will be actually weaker than 2-A-A-A because the suits is here is ace. But in camel card, they will do sequential ordering. So they will compare the first card, and then the second card, and then the third card, and so on. So for example, here the first card is 3, and the first card of the first hand is 3, and the first card of the second hand is 2. Since 3 is larger than 2, the 3-3-3-2 is the stronger card. And similarly, if it is 7-7-8-8-8-8 compared to 7-7-7-8-8, as the third card is of the first hand is 8, is larger than the 7, and the first 2 cards is the same, so 7-7-8-8-8-8 is the stronger card. Now we know all the rules about camel cards combination, and we can tell which hand is stronger than the other. As a result, we can also have rank and order based on all the possible hand combination. And now back to the problem. Our puzzle input are a bunch of hand and their corresponding bit values, and we are supposed to give them a rank where rank 1 is the smallest, and because of there are 5 inputs here, rank 5 is the highest. After that, we are supposed to give the summations on the product of each corresponding bit and their corresponding rank. So in this sample, we can see 32TK as only 1 pair, so we give them a rank 1. And QQJA is a 3 of a kind, which is the highest combination, and since it's a tie between T55J5 and QQJA, we do the sequential ordering, as the first card here is Q, and the first card of T is T, and Q is higher than T, Queen is higher than 10, and we give QQJA a higher rank of 5, and T55J5 a rank of 4. And based on the corresponding rank and their corresponding bit value, we do the summation, and in this sample we have 6440. As we have understood the problem, we will now try to solve it. Technically, you don't really need a computer to do this, and some people actually do mental calculation or even an abacus. But I'm a mere mortal, so I will let the computer to do what it can do best. In this problem, we will try to use Java programming language as I'm trying to learn the language itself. And bear in mind that I'm very new to the language, so if you have any suggestion to improve or even a critique, you can post it in the comment section or make a GitHub pull request. Okay, my first thought on trying to solve this complex problem is to dissect them into smaller pieces that is easier to manage, easier to code, and easier to test so that the bigger steps can be done accurately as well. And in this, we go backwards from what actually the problem needs is to give them a rank. So to give them a rank based on the combination. So we define this function get score combo, which is trying to uh, evaluate what's the right score for a particular card combination. And then we also consider this function, which is are these cards actually stronger? So even though the combination may be the same, like two of the hands are three of a cards, uh, are three of a kind, so we consider the sequential ordering in this function. And uh, as these two functions are essential, we realize that there are even smaller building blocks, that is card stronger. So in order to do sequential ordering, you need to make sure that we need to have a function that consider whether two cards are stronger than the other. So uh, yeah, here we define the function first. We define the method first, and then we'll try to give the right measurement, right? So in scores combo, uh, for example, we need to give a value. We need to give a high value to a combination that is a five of a kind or and which is higher than should be higher than the four of a kind, and the right data structure for this is a map of with the key with the string key, and the value will be an integer that is higher than the other. So this is the data structure that we need, and that's for the get score combo. And another one is for the comparing between two cards, right? And here we just simply uh, here have a map with the key is the character of the card itself. So here we assign ace to value of 14, which is higher than 4, which has assigned value of 4. And we have to ensure this have a sequential ordering, which so these are the first few things that we need. We define the functions that is required. Just uh, write it down first, the function, not the implementation. So these four functions are required: get scored combo, art card stronger, and then even the smaller pieces is the is card stronger, and the right data structure is to use a key value store, which here is a map of scores combo and scores card. Um, if you notice accordingly, then you will realize there will be so many words of joker, which is not relevant to the section we are doing right now, because the joker itself is for the second part of the day 7 question. After we have written down the methods that is required, and before implementing them, and we will write down the test cases first. So in this case, we'll be using JUnit 5 and parameterized tests to each of the methods that has been written down. Basically, to read these test cases is just, for example, is card stronger? The hand card is A, and the base card is T, will result to true. So we are expecting the output of the is card stronger A ace is high stronger than T, and so the result should be a boolean true. And so it's the same with other test cases. Here we are expecting queen to be stronger than 6, and the output of this function will result to true. And another one will be 9 is stronger than 5, so the output of this function is card stronger, it should be a true. The same goes for the other methods. The next one will be, let's check a get score combo, and here we are expecting assert equals, which basically means just we want the output to be correct. Like high cards, we are for example, in get score combo of 2, 3, 4, 5, 6, right? This is a high card, so we are expecting the value to be 0. And so another one is get score combo A S S S S, which is a 5 of a kind. And if you notice, we have assigned 5 of a kind to be a 6. So yeah, we will write down these test cases, like the relevant test cases, which is a 1 pair will be a 1, and these are the 2 pairs, which is 2 2s and 2 3s, which will result in the score 2. So that's basically how you read these test cases. Is simple output, sanity, and accuracy check. And another one is the R card stronger, which is done after having this score combo. In case of tie, when there is like a 3 of a kinds of multiple 3 of a kind, and we need this R card stronger, which is just sequential ordering. Okay, so for example, here we are expecting this QQQJA, which is both and T55J5, and QQQJA should be higher than T55J5, right? Not because of the because of the 3 of a kind, but because it starts with Q, which is higher than T. And then the next one is 2 pairs of KK677 and K3JJT, which both are 2 pairs. And we look at the second card. The hand card is K, and the second hand is T. So king is higher than 10, and so we are expecting this R card stronger to result to true. The same goes for the rest of the test cases. We now have written down the test cases, so we can start to define the methods to achieve the results of the test cases. We will take a look at the simpler functions first, which is whether is card stronger. As I said this before, the joker is for the second step, which is here simply the temporary map. If joker, then it will consider the cards the card score based on the addition of joker. Since this is not a joker case, we will refer to the score card, which is just the normal ordinal flow of regular poker card. And Since we use map, we will get the value by using the get, and we compare it with the more than operator. So yeah, after written this down, you run the test cases, and then you will see that hand card A is stronger than base card D, which ace is stronger than 10. Queen is stronger than 6, which is just as we expect. And then after defining the is card stronger, we'll then go to equals. I think this is just pretty basic. Instead of using a beta greater than, you will use the object dot equals. And then the next one will be we will go to the arc card stronger first. Here we just consider the sequential ordering, so we don't care about the combination or whatsoever. And basically we'll just iterate through each character of the hand cards. So the first of the zeroth card of the hand cards we will retrieve that and store it in variable char current hand, and then we will check whether the current hand is greater than the base. If it is actually greater, then it will simply return true. So that goes for the zeroth iteration, right? If it is the other way around, we will return to false. But then if it is equal, it will go back to the for loop and increase the I, so it will next be to the second or the first in this case, or yeah, the second one, and we will do the same thing again. We will take the second value of the character in the hand cards and then compare it to the second of the base cards, and we will check whether is card stronger, and if this is actually true, and then the function will close and return true, and it goes on to the next one. So if it is the other way around, it should return false, but if the card is equal, we will go for the third card. So yeah, that's basically the the implementation of the arc stronger method. And we go back to our tests and test them. Simply this is the arc stronger test, and we'll run the cards stronger test, and we see the result here. Hand cards QQQJA are stronger than base cards T55J5. So since all these test cases pass, we can ensure that this implementation is correct. The last method that we need to define the body is the get score combo. It's a little bit more complicated, and we will go through this step one by one. In this first section, we will try to have a map of count, which basically means for each letter that is available there, we will try to count them. So right, for example, we are expecting ace to have an entry of a key ace, and its value will be the count of ace, which is 5. So like that's what the count map store the character. So for example, in another case, is 8 8AA. So the keys are A and 8, and for the entry for for a key A, the value will be 4, and the entry with the key 8, the value will be 1. Uh, that's basically what these four uh, lines mean. We iterate through each card, and then we get the corresponding card with the current, and we will try to put it, and if doesn't exist yet, it will initiate to 0, and then we plus 1 to it. If it already exists, we just continue the addition. And the following line is only relevant to the joker section. And then after that, we will try to get the values and try to find the repeats, right? For example, the repeats here in the ace is 5, and this one will be a 4 and a 1, and this 2332 will be a 3 and a 2, and TT98 will be a 3 1 1. These are the sorted repeats. So these are basically what it is saying. So so it will return to you the get 0. We will use get 0 a lot, because the first value in this repeats list is the highest. If the repeats with 5 is a 5, it means it's a 5 of a kind, right? If all the value of the repeats is just 1 1 1 1, and then it will just be a high card. So again, this section is only correspond to the joker one, and we will get this. The output for the function itself, we will store it in the integer out, and it will return it later in the future. But the definition, the assignment will be in this nested if section. So if the repeats, which is the highest repetition, is 1, it will guarantee to be a high card. And then if the repeats.get 0 is a 2, it can be either a 1 pair, it can be either a 2 pair, right? So we will further check the second element of the repeats, which is just repeats.get 1. So if it is also a 2, then it will be a 2 pair. Otherwise, it means the repeats will be a 2 1 1 1. So it will be a 1 pair. Note that it will simply use the mapping that we already defined in the code section above, right? So since it is a 5 of a kind, it will be a 6. So the high cards will be 0 and 1 and 2, like that. So it will just be a simple mapping. And okay, and then go to the next one. If repeats get 0, it will be a 3. It can be either a full house, or it can be also just a 3 kind, right? So we will check the second value. If it is a 2, so it will be a full house, which is a higher, which is corresponds to a higher value. Otherwise, it will be the repeats will be a 3 1 1 1, right? So it is a 3 of a kind, and we assign the corresponding value to the output functions. As there goes the same with the 4 and the 5. Hence, we can conclude this get score combo has been defined, and then we test them. run tests. We run the get score combo test. We will check that okay, this there's a mismatch here, so it actually should be just A has a value of 6. That's what it actually means, but we mismatched them. But you get the gist. This is just a simple definition that I will fix in the future. So since all the test cases pass, so all these methods that we have defined are correct, right? Are already accurate. The is card stronger, the arc hard stronger, and the get score combo has been defined and passed the test cases. Now that we have defined the simpler methods and we have ensured that they pass the test cases, and we can proceed to use these methods in the bigger picture. Here we are at the last part of the problem, which is trying to stitch all the methods and actually solve the problem. And we can first take a look at the input, which is just a bunch of cards with their bits, and then it's a lot. That's why we code it. And I will try to explain line by line. And I've set up here a few breakpoints so that we can analyze it further. So we just start debugging. Okay, the first two lines is simply just reading of the input files, and as we can see here, it's the same line by line corresponding to the input text, and there's nothing special here. We can go next. Okay, basically here we are having cards and bits, which is to store them in a better data structure that will be useful in the future. So basically cards are just the list of cards that are in the inputs, and bits are the corresponding the value of a corresponding card, so it's stored in a map. So if we try to step out, all the cards and the bits are filled. The cards are the values, the hands, and the bits have a keys of the cards and their corresponding bit value, which is here Q for QKK will be a 465. Okay, the next part is the ranks, which is a data structure of a type of a map, with the first key is to be an integer, and it will be the value of each entry will be an array list of string. So as mentioned in the get score combo, in the get score combo you will have this kind of score. So the integer here basically will be the scores, and the arrays here will be the card strings that has the corresponding score. Note that this will be ordered as well, ordered based on the later on would be the R card stronger. And okay, we can just take a loop each step by step. So okay, our card now is Q for QKK. So since it's a 2 pair, it will have a score combo of 2. And then since the 2 is not in the map yet, it will just put the value. Okay. So here we can check the rank. We have integer, we have a key of 2, and in this 2 we have an array of one size, which is a q for qkk. We will go on further until few iterations. So the next card will be 28555. This is a 3 of a kind with score combo of 3, and then we put them. Since this is the only entry, we will just simply put them. So now if we take a look at the ranks map, we have 2 keys now, 2 and 3, both with a size of 1. Go on. Okay. 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 Now we have several keys here already filled, 0, 1, 2, 3, 4, 5, and we have different sizes of each array list. These are the array list of size 2. If we take a look, these are the values are here. Here the key is 1, and 1 correspond to the 1 pair. Here's the 9J242, which is a one pair of 2, and note that since 9, and then the second one will be JJQK2, which is one pair of J. Since 9 is lower than the J, we will put it at the lower index. Can further go, we'll try to fill as many as possible. Okay, now we have this, the one with the 4. We will take a look at the list. Here the 4 corresponds to full house. Full house will be 333 and DT, and the next one is 7QQ 7Q, which is the full house of Q and 7. This one is 4 and 8, and this one is T and 8. And after that, the order is based on the sequential ordering. Since 3 is lower than 7 and 7 is lower than 8 and 8 is lower than 10, it will result to this kind of array list. So yeah, that's basically what this code's about, and that's where the ranks is. And we'll just go outside of the iteration, and we will try to step out. Okay, now ranks have actually 6, and these are the corresponding size. We actually have a 5 of a kind here of a 6, which has a score 6, which is JJJJJJ. The cards ranked will be about laying all the ranks in one huge array list that is ordered based on their strength. And so in the ranks you will have these key values. Although the values are ranked, it still is in the 0 and 1, 2, 3, 4, 5, 6. So we just try to lay them out here, and we will try to lay them out. We will iterate through here, and if we step over, stop out, and we will get the cards rank value, and we finally get the ranks ordered. So we have 2, 3, 5, 6, 7 as 0 or equivalent to rank 1, and 249 TK is the next one, and it's all correctly ordered. So it's all this high card the number 20, the rank 29 or 30th, it's 3JK42, which is higher than the previous rank and lower than the 3K284. This goes on until another to a total of 1000 items. And after all this layout, we can simply calculate the bits, right? It will just be the here we set up a counter of winning, which is starting at 0, and we iterate to the card's rank, and every iteration we sum the rank, which is just the index and adding 1, and we get the bits based on the bits map that we set up earlier. And this goes on and goes on for 1000 iteration. And if we just step it out, you will get we will print out accumulation of the winning 2551366060. So if we take a look at the advent of code itself, and we input the value, and you will get the right answer, 2551366060. I guess that's it. That's my solution to advent of code day 7 part 1 problem. If you actually enjoy this video at all, feel free to likes, and if you have any issues or comments on the codes, and whether you have suggestions, feel free to put it in the comment section. Thank you for watching.